There were a couple questions that came in about question 14.14, so I just wanted to go over that because it kind of relates to trying to put together the rate law with what we know about the reaction. So we have this reaction 2C reacts with D to form J and 2K, and that's our overall reaction. And the key here is that the rate of the reaction is second order overall and second order in C. So from that information right there, we can figure out the rate law should be rate equals our rate constant times the concentration of C squared, and that should describe the entire reaction. The rate of the reaction equals the rate constant times concentration of C squared. That covers the reaction being second order overall and second order with respect to the concentration of C. And so what does that mean? That means, right, we talked about reaction coordinate diagrams, right? And we talked about steps, slow steps and fast steps. That means that the slow step of the reaction depends on the concentration of C. There may be other steps of the reaction, but they are much faster, and so they don't determine the rate of the reaction. So we might have something like this where we have, the first step has a really large activation energy, and then we have a second step with lower activation energy for our reaction. And that first step, that's where we depend on the concentration of C to the second order. So we need to now propose something that would explain that. And so other second order reactions that we've seen before, right, just generic second order reactions would be rate equals the rate constant times A times B. That would be second order because A is going to react with B, or rate equals the rate constant times something squared. In this case, A would react with A to go to the product. So that could be a case of a second order reaction where two of the same molecules react with each other. So with that in mind, we look over here. The first choice, C reacts with D to go to J and Z. No, that doesn't describe a second order reaction with respect to C because we just have one molecule of C reacting. This next choice, C reacting with C to go to K and Z, yeah, this looks pretty good because we have one molecule, two molecules of C reacting, and that would explain our second order relationship. We see two molecules of C reacting to form K and Z. Z is an intermediate, so sure, after this reaction we could start with C plus C. Down here we could form K and Z, and then in the next step K and Z could react with D to form J, and we form one more molecule of K to give us 2K overall. And that confirms that Z is an intermediate. It's used in this reaction. It reacts with D probably to make J and one more molecule of K in this hypothetical reaction. But the important thing is, right, two molecules of C need to react second order with C. One molecule of C, that doesn't help our reaction. C doesn't even show up in this reaction, so that doesn't help our case. And then we can cancel out none of these above because the second choice here does have is second order with respect to C. So hopefully that helps understand what that question was looking for.